The secret life of fat in your brain sounds like the premise of a thriller, and in a way, that's exactly what researchers are uncovering. For decades, fat in the brain was considered an innocent bystander, something present, but largely irrelevant to neurodegenerative disease. Plaques and tangles got all the attention, hogging the spotlight like celebrity villains. But now, scientists are revealing that lipids, specifically fat droplets inside microglia, are anything but passive. They're active participants in the story, and understanding their secret life may open entirely new ways to protect the brain. Microglia, the brain's immune cells, are supposed to be tireless, constantly patrolling, cleaning up misfolded proteins, and maintaining balance in the neural environment. They use fat as energy, powering their cleanup routines. But under disease conditions, something changes. Microglia begin storing fat rather than burning it, accumulating lipid droplets that slow them down and reduce their ability to clear harmful amyloid beta plaques. In other words, the brain's own janitors, once energetic and efficient, get bogged down by a hidden hoard of fat, invisible to the untrained eye but disastrous in effect. The culprit behind this lipid accumulation is an enzyme called DGAT2. Normally, it acts like a helpful organizer, turning free fatty acids into triacylglycerol for storage. But in Alzheimer's, DGAT2 overstays its welcome, producing more lipid droplets than the microglia can handle. The result is fat-laden microglia near plaques that clear almost half as much amyloid beta as their leaner counterparts. It's like discovering that the cleaners of your house have been secretly hoarding supplies in the closet, leaving dust and clutter to accumulate in plain sight. Here's where the story becomes optimistic. Researchers have found that if DGAT2 is blocked or prompted to degrade, microglia can shed their fat, regain mobility, and return to their original function. These cells aren't destroyed. They've been temporarily overpowered by their own lipid stash. Once freed, they clear plaques, reduce inflammation, and restore balance to the neural environment. The secret life of fat, then, isn't a death sentence. It's a reversible obstacle, one that science now knows how to tackle. This perspective fundamentally changes how we think about Alzheimer's. Instead of focusing solely on plaques, we can now aim to restore the brain's natural defenses. By keeping microglia metabolically fit and preventing fat overload, the brain can maintain its ability to protect itself, potentially slowing disease progression or preventing it altogether. Lipid droplets are no longer just background players. They are clues, signals, and targets for interventions that empower the brain's immune system. The implications go even further. Lipid droplet accumulation is observed not only in Alzheimer's but also in normal aging and other neurodegenerative diseases. This means that targeting fat metabolism could protect cognitive function more broadly, helping the brain maintain memory, clarity, and resilience for decades. Microglia, once burdened, can be revitalized, proving that even in the presence of hidden obstacles, the brain has remarkable capacity for recovery. There's a compelling human angle here, too. Fat droplets aren't inherently evil. They're only a problem when they accumulate excessively. Microglia aren't failing because they're broken. They're temporarily overwhelmed. That means interventions, whether pharmacological or eventually lifestyle-based, could restore their function and maintain brain health. The secret life of fat, then, is less a tale of doom and more a story of resilience, potential, and hope. So yes, fat in the brain has been quietly influencing the course of disease, but the news is positive. We now know the mechanisms, the villains, and the way to restore balance. Microglia can shake off their lipid burdens, regain their energy, and get back to their job of protecting neurons. Alzheimer's may involve plaques, tangles, and a cast of complicated characters, but understanding the secret life of fat opens the door to a future where the brain can defend itself, memories can be preserved, and metabolic balance reigns. The mystery isn't just revealed, it's solvable, and that's a story worth telling.